Swayam Prabha. Digital India. Educated India.
Hello, welcome to everybody. Today we are going to discuss a very important pump known as screw vacuum pump. The concept is good old, but the application is quite recent, in the sense last 30-40 years it has become very popular because of very fine capabilities of machining. With lots of CNC machines coming up, you can program the machines with beautiful clearances and various profiles you can program and machine. So, all these things have led to a new wave in vacuum pumps to make very fine pistons, very fine rotors, claws, etc. These are useful for most of the pumps, mechanical pumps, but particularly for screw pump, we are going to have a complicated shapes which can be programmed in a programmable lathe. So, this screw pump, what is its relevance to vacuum technology? In what way we operate these pumps, in which range? Is it an alternative to some existing pumps? Is it a necessity for certain applications uniquely? What are the precautions you take? And generally, what are the applications in which they are routinely being used at present? Okay. So, the concept that are going to be covered in this lecture are, we introduce the screw pump to you first, how it looks like, you get a feel of it. Then we will try to explain you the constructional aspect of it and working principles, the physics behind it, little bit of mechanism and precautions, etc., the working principles of a typical screw vacuum pump that is being used in several process applications all over the world now, particularly pharma and chemical, but it is also used in other sectors in metallurgy, electronics, electrical, and now people are trying to go into other sectors where hogging of very large chambers, even in space or nuclear technologies, you can use it. Metal degassing, steel you can use it, because they have got huge pumping speed. Their range is of the order of rotary pump range, but most important is they are very dry. So, dry pump is highly required for high and ultra high vacuum, as I told you in the claw pump. So, same issue is coming here. That is how the screw pumps are coming in a big way. Diaphragm pump also can produce very clean vacuum, but its pumping speeds are not high. So, screw pump has got a unique combination of very high pumping speed. They can even compete with water ring pumps and steam jet ejectors, etc., or they can work along with them to enhance their capabilities, and to put very dry situations in certain pharmaceutical and chemical sectors where the oiliness is not allowed. Even very large chambers, particularly large loads coming in steel degassing, etc., they can offer alternatives to existing solutions which are little cumbersome, like steam jet or things like that. So, that way the market is coming up for screw vacuum pumps. So, several companies started doing these things in the last 20-30 years mostly. Earlier it was not possible to make these things, because in poor vacuum, that is little higher pressures from 760 torr to 10 torr, etc., the mean free path is still 0.01 millimeter type of thing. Whereas, in dry pumps we need to maintain clearances between the housing and the rotors. So, that housing will look big compared to the mean free path. So, unless you reduce the clearances to very small values, which are possible with advanced machining, you cannot operate them at relatively poor vacuums or low and medium vacuums. If you go to the 10 power minus 4 torr minus 5 torr, no problem at all. Little bit of this way, that way if you machine, because even if it is 1 millimeter, it will look like a block to me, because mean free path is more than 20-30 meters. So, this concept is to be understood when we are using screw vacuum pumps for vacuum applications. There are screw compressors, they are lubricated, they cannot be dry because it has higher pressures, there will be back flow. So, there is a different style of using these screws, but of course, flow rates and throughputs, they are similar machinings and the mathematics behind it, all those things are somewhat similar, but the extra concept we need to worry here is the relative dimensions of the clearances with mean free path. So, these are the concepts in the working principle we will be covering. Towards the end, we will try to tell you some advantages of these pumps, unique advantages, followed by some standard applications for which earlier some other pumps are used. Now, also they are continued because of heritage, but people are now thinking towards new pumps. But the problem is the industries who manufacture these pumps for large applications like pharma and food sector or steel degassing, they need to also understand with the clients when they go up with their pumps and work with them and suitably modify or add some accessories to your pumps. You cannot say simply I supply a pump, and these accessories include like heat exchangers or preheaters or filters, etc., because the load that is coming from these industrial sectors is not the pure gas load that you are thinking. So, you will have to take care of these aspects. So, with those things, several advantages and applications are there for screw vacuum pump. I have given this introduction so that by next slide it will be simpler for me to cover. Well, I have taken these figures from some of the industries. For example, this slide is taken from, this figure is taken from Everest Vacuum, New Delhi. They manufacture very good quality screw pumps as well as roots blowers, and they also supply to various chemical and pharmaceutical. Similarly, there are many companies, they are supplying to various sectors. In fact, the quality of the pumps depend on the machining. In fact, when I visited Pfeiffer and other companies in Germany, they were telling all our output finally depends on the welder and the mechanic. If they do a shabby job, we are in trouble. Okay. So, fine finishing, very small clearances, and also the controls, and when it is connected, integrated with some other application, how do you take care of purities and filtrations or heat transfer problems or other related problems like corrosion, etc. You have to take care, not just a principle of positive displacement. So, you have to take care of that. So, these companies, I am sure they must be thinking 50% of the time how to interact with the clients, so that the associated aspects are also taken care along with simply supplying a pump. So, what is this pump? This is a positive displacement pump, because it is displacing. It is somewhat like our sugarcane type of screws, they are intermeshing, but the difference is they are not forwarding type of things. There are several varieties like Archimedean type of screws. Those who are interested go into the details. There is a lot of mathematics behind design of Archimedean screws, etc. The typical screws that we use in sugarcane are, they do not go forward everywhere. Both the rotors go inside, they penetrate into the slots of the other fellow, and sugarcane goes there and it will only press and do it. But the bearing concepts for both the rotors and the gear concept, so that you are running only one rotor, the second rotor will automatically get connected to that. All that concepts are same here also. And you cannot keep two rotors, two motors, because these are all synchronously running. If there is a mistake, you will not get proper vacuum. So, synchronous rotation is possible only if you connect one of the rotor to a pump motor through proper shaft seals, etc. And other side you can keep a gear assembly, so that this rotation is transmitted to the other rotor. And how best you can transmit, that varies from company to company. The way you make these bearings to handle this load of rotating bodies, and the way you handle the gearbox, it is very important that at every stage you maintain tolerances. And even if some lubrication is required in the gearbox, that should not be subjected to the actual rotors. There should be good sealing chambers. I would say not seals, sealing chambers. That seals are very important, because the actual area where these rotors are rotating, they are in dry atmosphere. Why? Because these rotors are not touching with each other, nor they touch with the housing. There is a gap, finite gap, though it looks like from the figure, for example, it looks like as if these rotors are almost touching. No, no, these rotors are not touching with each other, nor they touch with the housing, or you can say stator. And you will see here, you see, motor shaft is motor is connected here to one of the shafts, and gearbox, you can keep gearbox this side, that side, there are several designs. And similarly, water jacket is there for the entire body of the stator, because after all it is relatively higher pressures. It is not perfect vacuum, molecule density is not very small, particularly when it is operating at 100 millibar. You need to take care of heat of compressions, etc. And sometimes hot vapors come from the process, that time also you have to be careful. So, basically the the screw vacuum pumps, they have to operate under adverse conditions also. So, you have to take care of all those precautions while designing the bearings, while designing various assembly like seals. Seals are very important. They are isolating the wet sections from the dry section. Similarly, gears and cooling. So, that means in the design you will have heat transfer problems, you will have fluid mechanics problem. If you go to very low pressures, of course, it is molecular mechanics, and you will also have a little bit of thermodynamics if you go into the detail, but you will have a lot of mathematics also in designing these screws. The screws are not simple screws like what we see in our day to day life and all, because they are forwarding type of thing, and also different shapes are there to get different volumetric capacities, and compression ratio. After all, it is supposed to produce good vacuum, good flow rate, both are important. So, compression ratio is also important. If it is not just like a blower or fan continuously heavily sweeping the material, it is not like that. Compression ratio is important, vacuum level is also important. That is why it is called screw vacuum pump, and they are characterized by dry mode. That means, these rotors are rotating in a perfect dry chamber. So, they are very popular pumps. They belong to this dry section of medium vacuum pumps. What are those? Last class I told you, claw, scroll, and then screw pump and diaphragm pump. And there are other dry pumps like adsorption pumps, etc. They are not mechanical looking. I will explain that little later to you and next class. And later there are also dry pumps at ultra high vacuum level, turbomolecular pumps, cryo pumps. They are not to be compared here. These are mechanical pumps handling medium vacuum type thing. These people are busy with process applications. They are electronics and high tech applications. Both are important for a society. Okay. Basically, the screw pump will contain two intermeshing, synchronously rotating screws properly supported by the bearings, connected through one shaft to the motor, but with a synchronizing gear assembly, properly lubricated there, and different chambers are isolated using seals, and temperatures of those seals have to be maintained if necessary by purging, etc. All these precautions like what we do in normal machine, they are also here. So, if you look at any book, you can understand these things. I am not going to read out these things, but for saying that clearances are very small, but little bit of particulate contamination it can handle. But if you are keeping very big size particles, then you are in trouble, it becomes a grinder. And similarly, when acidic vapors or something are pumped, this corrosion or other problems may be there. So, you have to have some coatings on these things. So, there are lots of technologies associated with that, it is not just mechanical, coatings on these rotors, so that they can withstand aggressive environment, gas or aggressive vapors. Okay. So, already I have covered the constructional aspect, but again with a little bit more in detail, here you can get a feel of it. Different things are there like suction, screws, bearings, shafts and discharges, seals, timing gears and cooling gears attachments. So, these 1 to 8 are explained here. So, you can leisurely read these things, and if you have common sense, you can easily understand these are the rotors, water jackets and of course, gear assemblies and seals and motor couplings, etc., etc. Okay. And if you look at these things, they look like mirror images. They are rotating in opposite directions. Then only it will create suction and continuous passage of gases from here. Okay. We will see that working principle in the next slide, but from the figure itself we can understand. And those of you who would like to just get a feel of it, nowadays everybody wants little bit animation. Here is a figure. This is not a typical screw like this. They also manufacture screws in various models, because depending on the shape of the screws, different mass flow rates, different compression ratios are there, and sometimes progressively you are having compression throughout the shafts in a uniform manner, then heating effects can be suitably monitored. So, all those design features are there. I am not going into detail. Those who are interested can contact me. This I have taken from Bush Vacuum. They are also making very good quality pumps. Okay. So, the screws neither touch with each other nor they touch with the casing. Then only it is possible to produce high speed rotation, because no friction. Then only you will get good pumping speed, and then only you will get dryness, because if they are touching, then you have to have cooling, etc., more, or lubrication first of all. Okay. But still there is isothermal compression cannot take place always, there will be heating effects. That time this heat, this water jacket will take care of that. Okay. So, bearings, their design and at what time you need to replace them, all that a client will ask. So, those manufacturers who want to make these things, they should know all these things, metallurgical aspects, mechanical aspects, thermal aspects, fluid mechanics aspects, instrumentation aspects, then control aspects, electrical aspects, and then trolley mounted things and to suitable cabinet. Everything is important when you make a technology. Okay. And particularly when it goes into clean labs in semiconductor fab manufacturing or space and nuclear sectors, they all expect certain style. Okay. So, nowadays quality consciousness has increased, particularly in vacuum technology. Okay. So, you can see here slowly you will get different types of compression going on. Here see little the gaps are more, here gap is still less. Towards the end, that is where maximum compression can take place, but you can readjust it by suitable shape of these rotors. More or less uniform compressions can take place. This you have to take care of that. And also leakages across that from the front to back and all you have to calculate, because leakage, as you start compressing and pushing the gases towards the exhaust, leakages are actually taking that gas back again because of high pressure differences. You have to take care of all that. While doing so, you have to also take care of seal mechanisms and gear mechanisms and whatever associated instruments are there, etc. And sometimes the entire thing has to be flushed between two successive uses using certain suitable solvents, and that solvent has to be recovered again. Similarly, some purging of the gases may be required at various locations. All that I will discuss again when we discuss with applications. At that time, we will bring back these pumps, but that time we will add some heat exchangers, we will add some pre-coolers, we will add some filters, all that will come. I do not want to show that here. This session is only for production. Okay. So, I hope you understood how this working principle and constructional details of these things. Okay. So, basically because of no friction, very high speed 3000 rpm, even high speed can go there, and they can have very high throughput. I remind you again, in vacuum technology, throughput. We will not call it as mass flow rate, volumetric flow rate and the pressure product, that you have to take care, which is proportional to mass flow rate. Okay. So, 5 into 10 power minus 2 millibar is a good enough pressure, good enough vacuum for most of the applications. So, you can take care of good vacuum, you can also take care of huge pumping speed, a beautiful combinations of both the things. That is very important. So, whatever heating effects are there in various compression zones, you have to take care of that. That I already told you. And pumping speed itself is a function of pressure, because no pump is ideal pump that it will pump all the way from atmosphere to 10 power minus infinity or minus 10. No, no. We have seen already in rotary pumps, diffusion pumps, etc. Same thing here. In fact, in most of the pumps up to 10 millibar, they have got fairly good pumping speed. Afterwards, they start falling, and around 0.1 they almost approach 0. And you can use booster pumps, roots blower, to boost the pumping speed at the lower pressures and also to get a little better vacuum. So, the booster combination, I have again taken this figure from a standard model which they supply to many manufacturers in chemical, pharmaceutical sectors, etc. This is their standard product. Many companies manufacture like this. There will be some intercoolers, whatever the client asks, they will have to add to that, and control systems, etc. Little later, when you go for vacuum system design, I will also talk electrical aspects and wiring aspects and interconnecting piping effects and intercoolers, pre-coolers, exhaust management. You cannot leave whatever you want to out, because environmental fellows will come and stop you. So, how to do that, all that filtration. Similarly, when used for medical applications, bacterial filters, all that things are coming. So, you have to think many things in vacuum technology when you want to use it for process applications, and screw pump is giving a lot of opportunities for you to add on several things or add additional pumps. This can also act along with water ring pump or a steam jet ejector. It is not only competitor to them, it can also act in consultation with them, these pumps. That means, it backs or it precedes. You can get various series coupled effects onto that. Okay. Similarly, solvent extraction plants, which are very popular nowadays in chemical industries. So, chemical, pharmaceutical, metallurgical sectors routinely are thinking of using these pumps. So, I request all the youngsters, particularly mechanical and chemical engineers who are going to be employed in these sectors, they should know how to use these vacuum pumps carefully. After all, they are vacuum pumps in the relevant sectors. And steel degassing is a very big field. Later, I will take it up as a separate application. At that time, we will come back to all these pumps like steam jet ejector or this pump or a combination of this pump or roots blower. What is to be used? Why? We have to see all that. Okay. So, you can look at the pumping speed variations. This is not, I do not, it is not, I have not measured in my lab. These are all taken from a company, and again Everest Vacuum, and they manufacture vacuum pumps of different capacities. They can run on 50 heads and 60 heads, different capacities are there. And as usual, like a rotary pump, you can also use air blast if there is a huge moisture involvement or anything, or even moisture, because it gets heated up little in this pump. Heating is also an advantage. So, no problem, even vapors can be handled, hot gases can be handled, because chamber is also a little hot, but very hot gases you have to take care of pre-coolers. But sometimes it may condense some of those vapors, then this pumping speed is not utilized for the vapors pumping. Remaining gases or air leaks or any other vapors which are not condensed, which are not condensing at pre-condenser, they will start entering. Or you can use a booster. The moment you use 2-3 pumps, you should know where to use coolers, where to use various other things like filters and all, and how much length of the pipe you should use between the pumps, because when you go to the viscous region, it does not matter if you make little bit mistake, but in go to molecular flow, as we will see later, you will have to be very careful in properly designing the connecting pipe. You cannot connect a system like this, for example, from here this is a pumping unit. So, company gives, that is it, their work is over, but your system is somewhere in the second floor, then you connect it all the way, it may not work. So, you have to discuss with the pump manufacturers in before, what is the minimum distance. Some people do not like to keep the pumps next to them because of sound, because of pollution, or because of several other reasons. Okay. So, these things have to be taken care, and most of the pumps are quite rugged, I would say. They can give sufficient pumping speed and fairly good amount of vacuum like not 1 tar and all. But if you want to go to molecular distillation etc., you can add roots blowers. So, this way by combining pumps or combining some accessories like heat exchangers, filters etc., you can utilize the screw pump in variety of applications. What are those applications? Applications are because of advantages. Okay. For example, no lubricant is there, that is an advantage. So, there is an immediate application, even if existing food processing or pharmaceutical, they will be using. That is why I have given advantages and key areas. No contamination, no operating fluids like diffusion pump and all, that requires a oil. Such problems are not there, and very high efficiency due to internal compression, and they can also handle little bit of liquid and dust tolerance. We have to suitably design, of course, because two-phase flows etc., handling is little tough, and it can independently work up to 0.1 tar. That way it is like a competitor to the rotary pump. In fact, rotary pumps of large capacity are not available. In fact, the other day I was suggesting to some companies, you can even use these pumps in some unconventional applications which they have not thought over, like space technology and nuclear, where the chambers are huge, somebody has to pump. So, maybe they are using simple pumps like rotary or something, if they may be taking 4 hours, but if you use this pump, you may take it in 10 minutes, that is an advantage to them. Hogging, that is called initially. Every pump can produce 0.01 tar, but how fast, that is also important, or how clean it is. So, demand is coming that faster and faster pumping, cleaner and cleaner pumping, and lighter, and energy consumption should be as less as possible. So, all these 4 aspects have to be thought over when you make a industrial pump for several applications which are needed for day to day life. Okay. It is widely used in various applications related to food, pharma and metallurgical, semiconductor, even electrical and electronics etc. So, typical industries that a vacuum technology serves, in particular the screw pumps, because today's section is on screw vacuum pumps, include chemical and pharmaceutical, which I have been telling, vacuum furnaces, just I forgot few till now, but vacuum furnace is a very big area in metallurgy for casting, melting, a very large scale in steel, of course, steel plants, even in small scale alloy steels, many, even routine components, metallic components, alloy components, how are you going to heat treat them, anneal them, annealing furnaces, everything has to be done under vacuum to get suitable mechanical and thermal and other properties, corrosion and other properties, so various materials. There is a lot of research going on in metallurgy and material science under vacuum conditions. So, vacuum furnaces is going to be very important area, where the initial hogging can be done, even backing can be done by this screw pump along with a roots blower. Nowadays, they are using with a rotary pump, but the history of evacuation will create a oil vapor. But here, if you use a screw pump with a roots blower, right from 7000 millibar or 760 tar, you will not get oil traces. So, these things have to be there. Similarly, electrical application, vacuum impregnation, transformer oil purifications, for example, vapor phase drying. Similarly, various industrial applications like drying, textiles, and I am not going to read out these things, and food processing applications and various other industrial applications. You can go through these things and you can start thinking how to integrate various pumps or combinations of these pumps to various applications with certain precautions. So, this if you are more or less convinced, then you should start thinking the design aspect of these pumps, and when you are applying, how rugged they are, how do you machine it and how do you apply it, what type of accessories you are going to add, so that the screw vacuum pump is going to really give alternative solutions to the existing oily pumps. So, with this idea, we will again discuss these pumps when you go for chemical and pharmaceutical applications when we in the second half of this program. Okay. Thank you very much.